Download this code from codegive.com, link in the description below. OK, let's dive into the world of arrays and objects in programming, with a focus on how to use them together and how they differ from simple arrays. This will be a comprehensive guide with explanations and code examples. Understanding arrays. At its core, an array is a data structure that stores a collection of elements of the same data type. Think of it like a numbered list or a series of containers, each holding a value. Arrays provide a way to organize and access related data efficiently. Key characteristics of arrays: **** homogeneous data type *** all elements within an array must be of the same type, example all integers, all strings, all objects of a specific class. ** contiguous memory allocation * array elements are stored in consecutive memory locations. This allows for fast access using their index. ** fixed size, typically in many languages, like C++, Java, the size of an array is fixed at the time of creation. Some languages, like Python, offer dynamic arrays, lists, that can grow or shrink. Indexed access * each element in an array is identified by its index, position. The index usually starts from 0. So, in an array of size 5, the valid indices are 0, 1, 2, 3, and 4. Simple arrays, arrays of primitive data types. Simple arrays, as the name implies, are arrays that hold basic data types like integers, floats, characters, booleans, etc. Example, C++. Explanation, C++. One declaration * int numbers 5, declares an array named numbers that can hold 5 integer values. 2 initialization * numbers 0 equals 10, assigns the value 10 to the element at index 0. 3 access * numbers 2 accesses the element at index 2. 4 iteration * the for loop iterates through the array, allowing you to process each element. 5 out of bounds access * it's crucial to avoid accessing array elements outside the valid index range, 0 to 4 in this example. Accessing numbers 5 or numbers -1 would lead to undefined behavior, example a crash or incorrect results. Example, Python. Explanation, Python. One declaration / initialization * numbers equals 10, 20, 30, 40, 50 creates a list, which acts like a dynamic array, and initializes it with values. 2 access * numbers 0 accesses the element at index 0. 3 iteration * the for loop iterates through the list. Python's for loop automatically handles the indexing. For sum, function * Python provides a built-in function sum, to efficiently calculate the sum of all elements in a list. 5 dynamic resizing * the append method adds an element to the end of the list, and the del statement removes an element at a specific index. This demonstrates the dynamic nature of Python lists. Arrays of objects. Now let's move on to a more powerful concept, arrays of objects. This is where you store multiple instances of a class within an array. Why use arrays of objects? Organization when you have multiple related objects, storing them in an array provides a structured way to manage them. Iteration arrays make it easy to perform operations on a collection of objects using loops. Data structures arrays of objects are often used as building blocks for more complex data structures like lists, trees, and graphs. Example, C++. Explanation, C++. One dog class * we define a class dog with attributes, name, age, and methods, bark, getName, getAge, setName, setAge. 2 Array declaration * dog dogs 3, declares an array dogs that can hold 3 dog objects. Note, in C++, you can initialize the array directly during declaration, as shown above. Alternatively, you could declare the array and then assign values to each element using dogs0 equals dog, buddy, 3, and so on. 3 Initialization * dog dogs 3 equals dog, buddy, 3, dog, Lucy, 5, dog, Max, 2, creates 3 dog objects and initializes the array elements with them. Each element of the array holds a complete dog object. 4 Accessing objects * dogs I.bark, accesses the dog object at index I and calls its bark method. You use the dot operator, dot, to access members of an object within the array. 5 Modifying objects * dogs1.setName, Luna, accesses the dog object at index 1 and uses the setName method to change its name. Important considerations, C++. Default constructor * if you don't provide a constructor with arguments for your class, you need to ensure that a default constructor, a constructor with no arguments, exists. If you only provide constructors with arguments, the array declaration dog dogs 3, without initialization, will result in a compile time error. The default constructor is needed to create the individual dog objects within the array before you can assign them values. The initialization dog dogs 3 equals works because it creates and initializes the objects at the same time, so a default constructor is not needed. Memory management in C++, when dealing with arrays of objects that allocate memory dynamically, example using new inside the dog class, you need to be very careful about memory management. You'll likely need a destructor in your dog class to release the dynamically allocated memory when a dog object is no longer needed, and you'll need to ensure that the array elements are properly destroyed to prevent memory leaks. Example, Python. Explanation, Python. One dog class * similar to the C++ example, we define a dog class with attributes and methods. 2 List of objects * dogs equals dog, buddy, 3, dog, Lucy, 5, dog, Max, 2, creates a list named dogs and initializes it with 3 dog objects. 3 Accessing objects * dog.bark, calls the bark method of a dog object within the list. 4 Modifying objects * dogs1.set_name, Luna, modifies the name attribute of the dog object at index 1. 5 Dynamic size * the append method adds a new dog object to the end of the list. Key differences between simple arrays and arrays of objects. Feature simple arrays, example int numbers 5, arrays of objects, example dog dogs 3. Data type primitive data types, int, float, char, bool, etc. Instances of a class, objects. Content stores actual values of the primitive data type. Stores objects, which can contain multiple data members and methods. Complexity simpler to create and use. More complex due to the class definition and object interactions. Memory usage. Each element takes up memory according to the size of the data type. Each element takes up memory according to the size of the object's data. Flexibility. Less flexible, can only store one type of data. More flexible, objects can encapsulate related data and behavior. Choosing between simple arrays and arrays of objects. Use simple arrays when you need to store a collection of basic data values, example a list of temperatures, a series of IDs, and don't need to associate any behavior with those values. Use arrays of objects when you need to store a collection of entities that have both data, attributes, and associated actions, methods. This is common in object-oriented programming where you model real-world concepts as objects. In summary, arrays are fundamental data structures for organizing collections of data. Simple arrays store basic data types, while arrays of objects store instances of classes, providing a powerful way to manage and manipulate related data and behavior. Understanding the differences and use cases of each is essential for writing efficient and well-structured programs. Remember to be mindful of array bounds and memory management, especially in languages like C++.